Hello, and welcome to the HYDAC Australia podcast. I'm glad you're here. In each episode, we share practical insights, technical knowledge, and real-world solutions to help you get the most from your hydraulic and fluid power systems. Let's get started. So, on the previous episode, we've looked at the major cleanliness standards and why ISO 4406 has become the most widely used method for reporting hydraulic cleanliness. But that leads to another question. How do we actually measure particles that are often far too small to see? After all, we're talking about contamination that, in many cases, is completely invisible to the naked eye. This is where particle counting comes into the picture. One of the traditional methods is microscopic analysis. The concept is surprisingly straightforward. A measured sample of oil is passed through an extremely fine membrane. That membrane acts like a filter, trapping the contaminants while allowing the clean fluid to pass through. Once the sample has been filtered, the membrane is placed under a microscope for examination. Now you might think the next step is simply counting every particle on the membrane. Fortunately, it's a little smarter than that. Rather than just determining how many particles are present, the objective is to understand their size distribution. In other words, how many small particles are there? How many medium-sized particles? And how many larger particles? That information provides far more value than a single total particle count. With microscopic analysis, particles are grouped according to specific size classifications. Particles below the reporting size are excluded from the count, while particles that meet or exceed the required size are included. Larger particle classifications are then assessed separately. This creates multiple measurements from the same oil sample, giving a much clearer picture of what's happening inside the hydraulic system. An important point to remember is that these tests evaluate particle size, not particle material. Whether a particle is made of steel, bronze, rubber, wood, or another material doesn't affect the count itself. The measurement is based entirely on size. That's because the cleanliness standards are designed to report how many particles of a particular size are present, regardless of what those particles are made from. Of course, understanding the material may still be valuable for fault diagnosis, but that's a separate investigation. For cleanliness classification, size is what matters. Today, many laboratories use automatic particle counters instead of relying solely on manual microscopic analysis. These instruments produce the ISO cleanliness codes that many maintenance teams see on oil analysis reports. Automatic particle counters use a principle known as light obscuration. Without getting too technical, the oil flows through a very small measurement channel while a light source shines across it. As individual particles pass through the beam, they partially block the light. The amount of light that is obscured provides information about the size of each particle. The instrument then counts thousands of particles automatically and converts that information into the cleanliness classifications used by the reporting standards. It's remarkably accurate and allows particle counts to be performed quickly and consistently. When using automatic particle counters with the current ISO standard, the particle sizes reported differ slightly from those used in traditional microscopic analysis. Automatic particle counters report particles greater than or equal to 4, 6, and 14 microns, while microscopic analysis uses different reporting sizes. Although the reporting methods differ, both are recognized within the ISO framework. The important thing is understanding which method has been used when interpreting the results. Another interesting observation relates to the numbers that appear on an ISO cleanliness report. As the particle size increases, the reported particle counts should naturally decrease. That's exactly what we'd expect. Smaller particles are generally far more numerous than larger ones. If two or more cleanliness numbers remain exactly the same across the different particle sizes, it's a sign that something may not be quite right with the sample or the measurement. Statistically, that simply shouldn't occur under normal conditions. One of the strengths of microscopic analysis is that it also allows technicians to visually examine the contamination trapped on the membrane. Comparator charts can then be used to compare the appearance of the contamination with verified reference images, making it easier to estimate the cleanliness classification. Some technicians perform detailed particle counting, while others use these reference images to quickly determine the closest cleanliness class. Both approaches are based on established procedures. While all of this technology is fascinating, there's one point that stands above everything else: the quality of the oil sample itself. Even the most advanced laboratory equipment cannot produce meaningful results if the sample isn't representative of the system. The way the sample is collected has a greater influence on the final cleanliness result than almost anything that happens afterwards. If contamination is introduced during sampling, or if the sample doesn't accurately represent the operating condition of the machine, the reported cleanliness code may not reflect the true condition of the hydraulic system. In other words, good data begins with good sampling. It's a simple idea, but one that's easy to overlook. So, what are the key lessons from today's episode? Firstly, hydraulic cleanliness isn't something that's estimated by eye. It's measured using recognized international standards that provide a consistent language for reporting contamination levels. Secondly, while several standards exist, ISO 4406 has become the most widely adopted because it's internationally recognized and straightforward to apply. Thirdly, particle counting is based on particle size rather than particle material, whether it's performed using microscopic analysis or automatic particle counters. And finally, perhaps the most important lesson of all, even the most sophisticated measurement system depends on one critical step: taking a representative oil sample. Without that, the numbers simply can't tell the real story. Understanding how cleanliness is measured gives us confidence when interpreting oil analysis reports and helps us make better maintenance decisions based on reliable information rather than assumptions. In our next episode, we'll continue building on these fundamentals as we explore another important topic in the world of hydraulic filtration: evaluating filter performance. Thanks for listening, and we'll see you in the next episode. Thanks for listening to the HYDAC Australia podcast. If you enjoyed this episode, be sure to follow the podcast and share it with your colleagues. For more technical resources and product information, visit hydac.com.au. Thanks for listening, and see you in the next episode.